Francis Adrian Civisco, and I'm gonna teach you how to prove series using mathematical induction. But before we start, let me define what is a series and what is mathematical induction. Series is the sum of a sequence. A sequence may be arithmetic, geometric, etc. And mathematical induction is one of many ways to prove a conjecture or the assumed equation. Basically, mathematical induction has three steps. These are: first, the basis step or the verification. In this step, you are going to show that the equation can be proved. You will assume that P of 1 holds true if n is equal to 1. Second, the inductive step. This is the main part of the mathematical induction. You are going to assume that P of k is true if n is k, and your assumed equation is gonna be your induction hypothesis. And you are gonna show further that P of k plus 1 is true whenever P of k is true. And the last part, the conclusion. The easiest part of the mathematical induction. To make you understand fully, here are some examples.
So in this example number 1, you're gonna prove that the n term of this equation, the sum of the n term of this equation is equal to n squared. So first, verification. Let n is equal to 1. So you're gonna replace n by 1. 2 times 1 minus 1 is equal to 1 squared. Then 2 times 1 is equal to 2. Minus 1 is equal to 1. So 2 minus 1 is equal to 1. And 1 is equal to 1. So you prove that this equation can be proved using mathematical induction. So the second part, let n is equal to k. All you have to do is replace n by k. So 1 plus 3 plus 5 plus 7 plus 2k minus 1 is equal to k squared. So the 1 up to 2k minus 1 is your presumed hypothesis. It is also called, the answer of that is also k squared. So the next step is let n is equal to k plus 1. So copy again the equation, the series rather. 1 plus 3 plus 5 plus 7. Then replace it, plus 2 times k plus 1 minus 1 is equal to k plus 1 squared. So the next step is you replace the 1 up to 2k minus 1 into k squared. So there you go. And k squared plus 2 times k plus 1 minus 1 is equal to k plus 1 squared. Then simplify the equation. K squared plus 2 times k is equals to 2k. Then 2 times 1 is equal to 2. Minus 1 is equal to, expand it, k squared plus 2k plus 1. So simplify it again. It will be k squared plus 2k plus 1 is equal to k squared plus 2k plus 1. So you prove it. They're the same. So the last part, the conclusion, it's easy because you're just gonna write, therefore, p of n holds true for all positive integers. Example number 2, you're gonna prove that this series, the sum of the n term of this series, is also equal to n times n plus 1. So first, verification. Let n is equal to 1. Replace n by 1. So it will be 2 times 1 is equal to 1 quantity 1 plus 1. 2 times 1 is equal to 2. Then 1 plus 1 is equal to 2. So 2 is equal to 2. So you verify it. Then let's move to the next part. Second part, let n be k. 2 plus 4 plus 6 plus 8 plus 2 raised to k is equal to k times k plus 1. So your 2 up to 2k is your conjecture and it is equal to k times k plus 1. So next, let n is equal to k plus 1. So 2 plus 4 plus 6 plus 8 plus 2 times k plus 1 is equal to k plus 1 times k plus 1 plus 1. So you're gonna replace it. K times k plus 1 plus 2 times k plus 1 is equal to k plus 1 times k plus 2. So simplify it. K times k is equal to k squared. Then k times 1 is equal to k. Plus 2 times k is equal to 2k. Then 2 times 1 is equal to 2. Is equal to k squared plus 3k plus 2. Then simplify it again. K squared plus 3k plus 2 is equal to k squared plus 3k plus 2. So they are the same. Therefore, you prove it. So the last part, the conclusion. Therefore, p of n holds true for all positive integers. Number 3, you're going to prove that the sum of n term of this series is also equal to 2 raised to n plus 1 minus 2. So first, the verification. Let n is equal to 1. So 2 raised to 1 is equal to 2 raised to 1 plus 1 minus 2. 2 raised to 1 is equal to 2 is equal to 2 raised to 2 minus 2. 2 is equal to 4 minus 2. 2 is equal to 2. Therefore, it can be proved using mathematical induction. The second part, let n is equal to k. 2 plus 4 plus 8 plus 2 raised to k is equal to 2 raised to k plus 1 minus 2. So again, that is your conjecture, and it is also equal to 2 raised to k plus 1 minus 2. So the next is let n is equal to k plus 1. So replace k by k plus 1. So 2 plus 4 plus 8 plus 2 raised to k plus 1 is equal to 2k plus 1 plus 1 minus 2. So replace it because it is also equal to 2 raised to k plus 1 minus 2. Then plus 2 raised to k plus 1 is equal to 2 raised to k plus 2 minus 2. Since that and that have the same base, you'll just have to add their exponent. So 2 raised to k plus 2 minus 2 is equal to 2 raised to k plus 2 minus 2. So they are the same, thus you prove it. The last part, the conclusion. So again, all you have to do is to write, therefore, P of n holds true for all positive integers. And then you are done.
So that's all. I hope that you learned much about mathematical induction. Thank you for watching.